In this section, we'll be looking at calculating lengths in problems involving similar triangles associated with parallel lines. If we look at the first example here, we're asked to find x. There is no mention of the triangles being similar here, and first of all we need to make sure we understand there are two triangles in this diagram. So we have our large triangle around the outside and we have a smaller triangle in the inside here, so a small triangle. So what I would generally do in one of these questions, after I've established that these two triangles are similar, is I would want to first of all split them up into two separate triangles. But at the moment, because we're not told in this question the triangles are similar, we might want to look at why they are. So if you think back to our S1, S2 work, then you'll probably remember corresponding angles, which you might also have heard called F angles. So I've got that kind of F shape there, which means the angle in here corresponds to the angle here, meaning these two angles are equal. The same at the other side. If I was to take a different colour, I've got an F shape here, meaning that we have these two angles here corresponding to each other and therefore equal. Now at the top of this triangle, the same angle appears twice. It's at the very top of the triangle. It's the angle for the small triangle and it's the angle for the large triangle. So it's the same in both angles. So what I might say here as good practice is just to very quickly say that corresponding angles are equal, therefore triangles are similar. And if I know they're similar, I can then go on and do the work we've been doing previously. So, good practice in this question. Don't leave the diagram the way it is there. Different questions, they can appear in a multitude of different ways. It's always good practice when you've got one triangle inside another or two triangles in the same diagram to draw them out as separate triangles. Now, it doesn't need to be exact. It's just a quick sketch. I'm not using a ruler. I'm just doing this very quickly. So 6 centimetres and x on the small triangle, and the large triangle is 10 by 8. Now, again, same practice here. We're going to identify corresponding sides. So the x here corresponds to the 10 and the 6 here corresponds to the 8. So first of all, is it an enlargement or a reduction? Now in this case, I'm trying to find the x here. It corresponds to the 10. So I'll have to do something to this 10 to turn it into this x. So am I trying to reduce this 10 or enlarge it? Now this is obviously a smaller side, so I'm trying to reduce the size of the 10, so this becomes a reduction scale factor question. So I'm going to write that out. Again, remember this is a reduction scale factor for length. Using the two other sides which I have values for which correspond to each other, I've got the 8 and the 6, I need to create a reduction scale factor, so I want my fraction to be bottom heavy, so 6 over 8 will be my reduction scale factor. Now, I'm going to leave it as 6 over 8. Usually when I get a fraction like that, I would simplify it. However, if I'm going to be using a calculator for this, there's absolutely no need to be simplifying that. I'm just going to leave it as 6 over 8. In a non-calculator paper, it might be worthwhile simplifying that before moving on. So x is equal to 10 multiplied by your reduction factor, because remember I'm trying to reduce the size of the 10 here, and that's going to give me 7.5 centimetres. This example is slightly more difficult than the last one due to the way the information is arranged on these triangles. But first of all, we need to establish, are the triangles similar? So very quickly, just having a look at those two angles there, they're corresponding angles due to the parallel lines. And then we have these two angles here, also correspond to each other, they're going to be equal. And at the top, because the two triangles, large and small, share this angle, that's obviously going to be equal. So again, we can state that our corresponding angles are equal and therefore our triangles are similar. What I then want to do is to draw out these triangles separately. So we'll start with the small triangle and the larger triangle. Now, if we've got here on the small triangle, we should note that's 5 and 3 centimetres. And on the large triangle, it's slightly different. We've got 8 centimetres at the bottom, there's no argument about that. But at the side, the entire length of this longer side here, we don't have an exact value for. We have an expression, maybe we have the x plus the 3. So again, I'm going to look at matching up my corresponding sides. So this 3 here corresponds to the x plus 3 in the larger triangle. and the 5 down here corresponds to the 8. Now our unknown value is the x plus 3, so what I'm looking to do is, by looking at these two, say what am I trying to do to this 3 here to turn it into this larger side. So am I looking to enlarge this 3, or am I looking to reduce the 3? Now the 3 here is the smaller side. I'm trying to change it to a larger value, so I'm trying to do an enlargement scale factor question. Now to get my enlargement scale factor, I take the two corresponding sides which I have values for, and remember, for an enlargement I need to create a fraction which is worth more than 1. So using the 5 and 8, to make it more than 1 it needs to be top heavy, so 8 over 5 will be my enlargement scale factor for length here. And then what's different about this question and others is usually I'd be starting by saying x equals, but in this triangle up here it's not just x on its own, it's x plus 3. So that longer side is x plus 3, and it's going to be equal to our 3 centimetres on the smaller triangle multiplied by that enlargement scale factor of 8 over 5. Now this is again slightly different due to the fact I've got this x plus 3 here, and I'm going to want to get x on its own. I'm going to have to solve an equation by eventually subtracting 3 from both sides. So I'm going to keep this together. I'm going to leave the x plus 3 here and multiply the 3 by 8 over 5, which is going to give me 4.8, and then I have a basic S1 equation there, so I can start by just subtracting 3 from both sides of the equation, and I end up with x equals 1.8 centimetres. What we have in this example is another common example of triangles where parallel lines are used to show they're similar. So basically we have our alternate angles, which going back to S12 you might have heard referred to as Z angles, showing that this angle and this angle here are equal. And the same applies in the other direction where we've got this kind of Z shape. So this angle up here and this angle down here will be equal. Lastly, we can see that the two angles opposite each other are vertically opposite angles. If you remember back, these will also be equal. So again, the corresponding angles in both triangles are equal, and therefore we can say the triangles are similar. Now again, I want to draw out these two triangles, and in this example in particular we need to be really careful when we're doing that. So let's take our first triangle, and I'm keeping the red, blue and green dots in there so we can see what's going on, and we'll try and illustrate what's so important about that top triangle. When I draw out, I need to be really careful that I am rotating it around to match up with the orientation here. So if I was to bring that down, that's not really a lot of use. They're not orientated the same way. So what I want to do is kind of think about rotating that round, and then we'll sort out those sides so the right way up. And from that point onwards I can just proceed as normal. I'm going to start again matching up our corresponding sides. So the x that I'm trying to find corresponds with the 19, and this 6 here, it corresponds with the 13. In this case, this 7 here has no use in this question whatsoever. So again, I'm trying to find x, which means I have to either enlarge or reduce the 19. So to get from 19 to this x, from this long side to the shorter side, am I going to have to enlarge it or reduce it? So obviously I'm going to have to reduce it. So it's a reduction scale factor. And it's for length again. And looking at the two sides which I have values for, which correspond to each other, the 6 and the 13, careful not to use the 7 here, 13 and 6, if it's a reduction I need a fraction which is less than 1, so it'll have to be 6 over the 13 rather than the other way around, so 6 over 13. All I then need to do is state that x is equal to the 19 on the larger triangle, which I'm trying to reduce using my factor of 6 over 13, and that on my calculator should come to 8.8 centimetres.